Okay class, let's continue on the last example on the current divider, how we can solve this one for the AC circuits. So given 10 cos 3t plus 45. Okay, one resistor and one capacitor. Okay, first always change everything to phasor. So you become here, it's already cosine, so 10 angle 45 degree. Then you have 4 ohm. And then you have a capacitor. So this capacitor you're going to change to the phasor. So become 1 over, the omega here is 3 and 1 over 6. So it become minus J2. So just put here minus J2. Okay, your aim is you are going to find the current across here. So by using current divider, so what is the function of the current divider? By current divider, I is equal to the opposite impedance minus J2 divided by minus J2 plus 4 multiplied by the source 10 angle 45. So by just using your calculator, you can get the I is equal to 4.472 angle minus 18.43 ampere. Okay, so this is actually the capital I. Now let's change to the time domain. So you can get here 4.472 cosine. The omega is 3t minus 18.43 ampere. So this will be the answer for the first part. What is IT? Now let's see the second part. What is VT? So let's say the VT here is the voltage across the capacitor. So first we need to find the current across the capacitor. So again, by using the voltage divider, what is the current? 4 divided by minus J2 plus 4 multiplied by 10 angle 45. And then you can get here 8.94 angle 71.56 ampere. But the final one, you want the voltage across the capacitor, right? So the V is I2. The V2 is equal I2 ZC. ZC means minus J2. So you just multiply together 71.56 multiply by the impedance of the capacitor, that is minus J2. This is ZC. This is I2. Then you can get your V2 is equal to 17.88 angle minus 18.44. If we transform this one to the time domain, always leave your final answer in time domain. It become cosine, the omega is 3t minus 18.44. Don't forget the unit. So this is how you apply the current divider inside your AC circuits. First, always change everything to impedance and also the phasor, and then you just apply your current divider as normal. So let's recall, here is, let's say you have 3, you have 2. How you find the current I2 here? So I2 is the opposite, resistance 3 divided by 3 plus 2 multiplied by the total current. So you the same thing apply here. You want to find the current here, so here you put the opposite, and same here you want to find I2, you put the opposite divided by the total multiplied by the source. Okay, so I put it wrongly. Here is actually the current source. That's where you can use the current divider. Okay, so I hope this helps. So in the class we will discuss how we're going to solve this current divider by having two elements here, 4 and 1 over 12, 8 and 3 Henry. First step, always change everything to the impedance, either inductance, impedance, or the capacitance, right? By having if inductance is actually J omega L, if impedance is 1 over J omega C. and also change your source to become a phasor. What is the phasor? It need to be cosine. So once change to the source, you look at which one is series, which one is parallel, and then number 3, you just apply your current dividers. So I hope you can try this by yourself, and we can discuss in the class next week. So this will be the end of the chapter example for chapter 9. So there are more examples here, so we will discuss this in our class. So I will find what you have learned in chapter 9 is all about AC circuits. So we have what we call phasor form here, where everything need to be cosine in order for you to form the VM and theta. Okay, and also you learn about lead and lag, how you're going to define which one is lead and lag. Both need to be either sine or cosine. And then you learn about what we call impedance. What is impedance? Is the same as resistance, but this impedance is actually in the complex number, where it consists of resistance and also X here is actually reactance. It have what we call, from the resistance is J omega L, in for the capacitor is 1 over J omega C, and finally you have the admittance is actually 1 over Z, is opposite of the impedance. Okay, so please try by yourself, and we'll discuss in the next class inshallah. All the best in your midterm. Assalamualaikum.